Yes, thank you, ma'am. I think I am audible.
Yes, you are audible.
Yeah, ma'am. So first of all, a lot of thanks for inviting me and for giving this nice introduction. It means a lot to me. So a very good morning to all the participants and the panel members. So just let me share the slide.
Can you also just for a while, if you can open your video so that participants know who is teaching and who is speaking, if you don't mind, Dr. Suel. I think he is again out from, there's some, you know, that Northeast areas are having certain problems. We are waiting for him. So basically today's session, because he has worked on a couple of works that I could see is on healthcare, applications of blockchain technology in healthcare. Some of you were very keen to know about how blockchain can be applied to applications like healthcare. So he has worked on healthcare, and perhaps, as I'm sure that, as I can see, that he can deliver a talk on blockchain technology for healthcare. We're extremely sorry for this delay due to some unforeseen reasons that happens in this. Yes, he has joined again. So perhaps he was disconnected due to some poor network. Dr. Suel, over to you.
Yes, ma'am. Yeah, there was a network issue.
Yes, yes.
So just let me share my slide.
Dr. Suel, are you there?
Yes, yes, ma'am. I'm just sharing my slide. Okay. I think I'm not permitted to share my slide.
No, you are a co-host. So co-hosts are having all privileges like host. So you can share your slide, yeah. What kind of desktop or laptop do you have?
Dell.
Pardon? Dell. So Dell should not create any problem. Sometimes Apple products have some non-compatibility issues, but Dell you can definitely.
Yes, I'm also.
There is something like green box there, share screen. Can you see that?
Yes. You
can see that? There. Okay.
I know.
So you are not able to share there?
No, it is not. I'm unable to click on that option.
Sharing. It is sharing. Now it is sharing.
No. Okay. Fine. Actually, previously it was, I was just unable to click on that option.
Okay.
Okay.
I don't know how. Fine. So can you make it full slide?
Yeah. Now I think it is visible, ma'am.
Yes, visible, but
yes.
Full slide. Yeah, now it is full slide.
Yeah. So participants, sorry for this small interruption. So let us start. So directly, I'm just going to outline. So this presentation will go like this. At first, we'll just check some brief introduction about blockchain, and then some details about smart contract, and then how blockchain could be used in healthcare. And after that, we'll see one use case, like how actually blockchain is being used in the healthcare sector. And at last, we'll just discuss about some future work direction as well as the conclusion of the entire PPT.
Dr. Suel, I would like to tell you that for this, we are running this course for 6 days now.
Yeah.
So they are already exposed to what is blockchain, what are smart contracts, and all those things.
Yeah,
so if you can, I mean, accordingly keep your pace. Thank you.
Yeah.
They are more interested in how in healthcare it can be applied.
Yes.
Thank you.
Yes. So that's why I'll not spend a lot of time on this particular topic. Just brief details I'll go through, and then directly I'll jump to that particular section, that is healthcare. So just let us discuss about some brief details about blockchain. So as ma'am just said that you have already gone through the brief details about blockchain. So it is nothing but a set of connected blocks. So there could be multiple blocks, or there could be a huge number of blocks which are interconnected by using some hash, and they are making some network, or directly we could directly say that it is a connection, or it is a network of peer-to-peer network, and it is decentralized. And in particular blockchain network, we are just using this distributed ledger technology. So basically, as you people already know, that ledger is a collection of some records. So mainly it is a, in normal time, it is a like one big book or one copy in which we just record all the information about accounts. So here in distributed ledger technology, whatever we are just doing, we just keep the same information to all the participants on node. So there could be multiple nodes or users, or there could be some like desktop, laptop, or mobile devices. So they are keeping all the data, or we directly say all the data or block usually keep the identical information. So for example, if I am just keeping information A, so all the blocks or all the nodes must have this particular information, that is A. So history I am just keeping. So this is the simple scenario of blockchain network. So as you could directly see it, so it is a collection, collection of blocks. So here each and every block is connected by using its hash value. So you could please check it that in the first block, that is the Genesis block. So in Genesis block, there is no link up with the previous block. This is because it is a starting of the block. And after that, block number 2 and block number 3, block number 2 is connected to block number 1 by using the hash value of block number 1. So that's why you could directly see it in block number 2. There is the link of previous hash. The same is in block number 3. Block number 3 is connected to block number 2 by using its hash. So thus it is making one chain of block, and it is making one network. As I have already mentioned earlier, it is like peer-to-peer, distributed, and decentralized. So decentralized feature, that means there would not be any central authority or any third party who used to control all the tasks of the particular network. So that's how it is making a big impact in several sectors like healthcare, then banking, then IoT field, cloud computing, big data, wherever security type things are there, in those use cases, directly we could use blockchain technology. As well as, I have not mentioned yet, supply chain management. In supply chain management, it is a huge impact, because by using blockchain technology, we could make the entire system so transparent, so that all the entities could see all the details of the network, like what is happening, how blockchain is generating, what is the information being updated, and if there is any change, they could easily rectify it, identify it by using the signature. So I am not going in detail. So all of you, I think, and I believe that you already know about the permission, the types of blockchain network: permissionless, permission, then hybrid, and consortium blockchain network. So basically, I am not going in depth. So nowadays, actually, public blockchain in public blockchain there is so much security issues. So that's why private blockchain is much popular than public blockchain network. So characteristics and all, I am not going in details. So all of you already, I think, know that there would be smart contract, consensus algorithm, hash value. So all those things would be definitely there in a blockchain network. So some advantages of blockchain network is security, verifiable, distributed efficiency. All those things I am not discussing. So application, I have already mentioned that banking, finance, then business, government sector, and other industries. So in other industries, like here, we could directly say about automobile companies. So in automobile companies, there could be uses of blockchain network to develop an efficient supply chain management process. In government sector nowadays, in many countries, there is a voting system, and in voting system, by using blockchain technology, there is a voting system so that no one could directly manipulate any vote, as well as the government official could directly check what is, how many count is there. I mean that, like how many voted has been casted, and who is the winner, who is the who lost. Everything could be there in a short span of time. And banking and sector, as I have already mentioned, like that, for first transaction to settle the transaction in a short span of time, we could use blockchain network. So here in cryptographic primitives, there is so many things are there, like public key, there are so many things are there. However, I have just mentioned here SHA-256. So this is basically one hash algorithm. The main property of hash algorithm is that if there is any data like ABC or BCD, any name, so there would be some specific hash value, like 256 bit would be there. So for example, if I am just giving one information, like my name is, I'm just giving my name, so it is creating one specific hash value. From that specific hash value, you cannot get the actual data. So that is one kind of one way hash function. So that's how it is making difficult for the hackers and malicious users to get the original content of the data. So here I'm not the entire details are there, like how the entire process of SHA algorithm is happening. I'm just mentioning that it is one kind of hash function would be there, which converts one input value, or directly we could say plain text value, into ciphertext by using that particular function. And from the ciphertext going back, it is quite difficult for malicious users as well as hackers. However, nowadays on internet, you could find so many websites that supports to find that from ciphertext to plain text. Whatever they are doing, they have some set of blocks or some huge set of dictionary. They used to hard coded all the combination. For example, if I am just giving A and B, two character, what code would be generated? So that is already hard coded. So thus they used to support to convert one hash value to its original value. However, in normal cases, it is not practically possible, because to guess a huge number, which is 256 bit, it is almost impossible. Nowadays, in almost all the website in which we have some login features or some authentication is happening, in all those cases, this such kind of hash function is being used. So here I am not just discussing all those things just to save time. So structure of the block. So basically there are block headers and block body. So in block headers there are block version and which previous hash, timestamp, Merkle root and nonce. So here two main important terms are there, Merkle tree and nonce. So I hope you people already know that nonce is nothing but a long number which is used to find some or to solve some mathematical puzzle. For example, we would be given some puzzle, and in that puzzle there would be some numbers. By using that number we have to solve that particular puzzle. So once it is done, that means the block would be generated and the new block would be added to the network. Okay, so this is the main concept of nonce, and Merkle tree will go through Merkle tree in the next slide, just brief details. So in Merkle tree, basically this is one tree data structure in which there would be some parents node, as you already know, and then leaf node. So the leaf node is basically having the transaction details. So it is actually binary tree, so that's why all the leaf node is actually basically in this particular tree, the leaf nodes are having some transaction details or any kind of information, and the parent node of that leaf node is having the uh, hash value of that particular leaf node, and after combining them they are making one hash value. Like that, it is just going on to the upper higher level, and finally it was making one hash value for the entire information. So for example, in this particular slide, you could directly see that, for example, the leaf node are having so many information like country name, France, Germany, Denmark, all those things. And for each and every leaf node, there is one hash value. For example, for France and Germany, there are two hash values, and those two hash values are combined to generate another hash value in this particular position, in this particular level. And after that, these two levels are again making one hash value. Like that, it is, and it is making only one specific hash value for the entire block, and this is saved in the blockchain network. So if anyone like any malicious users or any attackers, if hack any leaf node like Sweden, if it just change it, then this particular hash value, the parent node, the hash value which is given in the parent node, it would be modified. That means this particular, the hash value of the higher level would be again changed. Like that, the upper or the root parent node or root node, or the hash value of the root node would be again changed. So thus even one small change would make a drastically change in the Merkle root hash. So thus it is making the entire system immutable. Thus any hackers or malicious users would not be able to hack any information. So this is the basic things about Merkle tree. However, I am not going in details. So there are basically two types of node in a blockchain network. Full node, basically full node has all the power just to mine as well as to broadcast all the information. So mine is mining process, that means only to generate one block, and this particular block is added to the blockchain network. And once after that particular block, there could be so many subsequent block after that newly generated block. So all those newly generated block ensures that the subsequent generated block ensures that the newly generated block is valid, as well as other miners. Basically in a blockchain network there would be so many miners. It is not like that there would be one or two miners are there. There would be multiple miners or who validate the transaction, or any, or directly we could say who adds any block to the blockchain network. So if there is any change in the, or if there is any malicious users who used to mine a block, so at that time its signature is not validated, because after mining process the miner used to broadcast one message to all the other miners who are present in the network, like you just validate the transaction by using the signature. So if there is any malicious users, then the particular signature will not be validated and it would be discarded. So the full node has all the power to mine as well as to broadcast all the messages. However, in lightweight node, it is just responsible to forward some information to the full node who are eligible for mining process. So in block generation, there are four processes: dispatcher token, broadcasting of transaction, then selecting a transaction, and mining the signature and creating a block and adding a new block. Even though there are 5 phases are presented here, in many places or many researchers consider the fourth and fifth phases in together, like mining and adding the block they used to consider in one single phase. So smart contract, you people already know, basically it is nothing but only to automate the entire process. In smart contract, whatever we are just doing, we are just programming some values, or we are just hard coded with some if and else conditions are there, and there could be some corresponding action. So once that particular if else condition gets satisfied, after that the corresponding statement would be executed and the entire blockchain network gets automated. So in this regard, there could be some triggering, like when the particular if else statement would be executed, like whatever the code we are doing in C code or C programming or Java programming, like if the value of x equal to 50, then there could be some process like authentication, like data access, anything could be there. So this is basically one if else condition, and there could be some statements, so that whenever there would be some predefined whenever the predefined conditions get satisfied, at that time the uh, action would be taken automatically. So this is the main concept, or directly we could say the backbone of the blockchain network. So consensus algorithm also I am not going in detail, because in consensus algorithm there could be, as I have already mentioned, that there would be multiple blocks or numerous nodes in the blockchain network. In consensus algorithm, whatever they used to do, they used to agree on some protocol, like, okay, these are the features or these are the rules and regulation, how the entire network uh, would be working. All those things actually depend on this particular consensus algorithm, like how they are agree on any protocol, like accessibility, security, scalability, then peer-to-peer network, who would be handling, and how the data would be stored, how many miners would be there, and what would be the features of miner, and what would be the difficulty of that norms. All those things depend on this particular consensus algorithm. So here, proof of work is one of the most important consensus algorithm. Basically, in Bitcoin, it is used. So here, actually, one signature is broadcasted to the all the miners for verifying, okay, this is I have just generated this newly generated block, and you people please verify it. So as it is just like one kind of work done by other miners as well, including the miner who is just adding the newly generated block. So that's why it is known as proof of work. So as ma'am said that you people have already gone through all those details, so I'm just quickly covering this topic. So here in this proof of work, this is one simple scenario. You could directly find it out. This particular flow chart here, there would be some transaction or data value which need to be verified, because as I have already mentioned earlier, one block is nothing but a collection of transactions, or there could be some collection of value or any kind of information. So once a miner used to mine that block or add that block, at that time there would be what? There would be some token or some gas value, or gas, that means some kind of directly we could say some cryptocurrency or some charges would be there. It would be broadcasted through the network as a token. After that, the server generates some mathematical puzzle, as I have already mentioned earlier. Then miner used to solve that mathematical puzzle by using one nonce. After that, whenever a node gets or find that particular nodes to solve that particular puzzle, then it is broadcasted to the network. Like, I have already generated the block, you people please verify the solution. So if it is solution in terms of signature, so once it is verified, then the block is added to the network, because all other miners just gave their agree, okay, this block is valid and signature is also valid, we could add it to the blockchain network. If it is not, then the entire process is just cancelled. And one important point here, we just need to consider that once a miner adds a new block to the blockchain network, at that time he or she will get some reward in terms of like cryptocurrency or gas value or some kind of any kind of reward. So here one important point that we should consider, that miner should have high computational power, because it is not like that to find that nonce it is very easy. For example, if I give one number 19, so it is not like that it is so easy to find in a blockchain network to find this particular number. There is one one area is given whenever we just solve any proof of work or any mathematical puzzle. So from that particular area, we need to find that nonce. So to find that nonce, it is not a very easy task. The miner used to means gradually or continuously used to perform this particular task to solve that mathematical puzzle. So that's why it is taking so much time as well as effort. So that's why any miners must have high computational power. Okay, so I hope you people already know this concept. So now we directly going to the concept of how blockchain could be used in healthcare. So this is a simple discussion. What is healthcare? As we already know that healthcare is nothing but a collection of service by which we get some treatment, or like we just used to go some medical diagnostic processes for any diseases. The entire scenario like lab as well as treatment, the entire thing comes under healthcare. So basically it is very complex and dynamic system, because here it is not like that only one or two entities are there. There would be involvement of so many entities. I will discuss in detail in further slides. Dynamic in the sense because there would be many users in the particular network. So if there are so many networks, so many users in the network who are like they are coming and going, so, okay, I am a patient, I am coming to the hospital. Whenever I am just coming to the hospital should keep all the details of mine, and whenever I am just going out from the hospital, or when the treatment is already over, after that also the hospital should keep that record, so that in future if there is any kind of problems regarding the same disease or same complaint, then all the previous details should be easily gathered from the database. So there could be numerical factors that affect in the healthcare sector, like demographic changes, technological advancement, because each and every day new devices are being developed for giving efficient healthcare services. So here access control and security is one of the two major factors in a healthcare sector. So I'll come in those aspects in detail in future slides. So there are mainly three types of healthcare system. First one is universal healthcare system. In universal healthcare system, basically the government provides all the services to all the citizen of a nation. So it is not like that there would be some partiality. Okay, one rich people would get one service and another poor people would get one service. It is not like that. All the people would get the same services, and the government used to pay the fee as well as charges or salary to all the for all the belongings to the network or healthcare system. For example, there could be charges for medicine, lab test, then salary of the healthcare professional for providing the entire infrastructure. Then there would be uh, some information system or information management system by which all the information is uh, managed. So all these things are done or managed by using the uh, government. So in the second type, national healthcare system, basically there are government uh, government sector is involved. However, there is the involvement of private thing or private aspect is also involved here, because here health insurance come into the phase. For example, if I just pay, if I just suffer from any disease, and if I have some health insurance, something like that, then I could directly get money from that health insurance company. And private healthcare sector, as we already know, it is like that. There would be directly a nursing home, such kind of thing. So the entire thing is handled by any private organization. It is basically provides high healthcare services. However, the cost is so much high. So some important aspects of a healthcare system are: first one is leadership and governance. So this is like who is leading from the front, as well as what are the rules and regulations that must be followed by all the entities involved in the healthcare system. So uh, to generate or to form some rules and regulation, that is quite difficult, and it is one of the major important factors in any healthcare system. Then the second one is financing, because financing is without finance or without money we cannot do any task, because we need to buy some advanced equipments, as well as there should be some purchase of medicine, or salary aspects is also there. Everything is managed only by using finance or capital. Then health workforce. So in health workforce, there could be involvement of many entities, starting from the uh, ground level staff, or directly we could directly say like housekeeping staff who used to clean our floors of a healthcare system, or directly we could say hospital. Okay, after that there could be some dressing staff or some nurses there. Then after that there could be some doctors, and above them there could be some departmental departmental head, and above them there could be some superintendent or some HOD type of thing in any healthcare system. Along with them there could be some other important workforce or work people are there, like pharmacists, then lab technician who used to test our many kind of lab tests, like blood test or like CT scan, all those things they are doing. Then a pharmacist, as I have already told you, people already know it, what is the work of pharmacist. So after that, healthcare product. So in healthcare product, basically we are just considering uh, several medicine, as well as uh, advanced equipments which are used in a particular hospital. And after that, healthcare infrastructure. Infrastructure belongs to like whether there is proper infrastructure or not, like if there is any uh, room, whether proper ventilation, and then if there is any hospital, whether there is any proper operation theater is there or not. And then everything means from the entire building, whether it is in proper format, whether it is hygienic or not, everything is, it is considered in healthcare infrastructure. And the last one is health information system. That is where we are just dealing with. So in health, information system, it is dealing with how the data of a healthcare system is being used, who is able to access the data. For example, if I am a user or if I am a patient, I am not eligible to get the information of another patient. Okay, for example, if I am a doctor, and if I am dealing with orthopedics, or if I'm a specialist in orthopedics, then I would not be able to get the information of another patient who already got treatment in another department. Okay, so like that, like medicine or something else. So like that, there is the involvement of a proper information system, like who is eligible for what. So there would be the involvement of access control, then database, then security. The entire thing is managed by the IT professional in this particular health information system. The next is coming directly, we are just going through e-healthcare. Basically, e-healthcare means electronic healthcare. However, this E does not only stand for electronic. There is many E's are there, like 10 kind of E's are there, like efficient, encouragement, ethics. So in e-healthcare, everything is dealing with is dealing in digital format, or there could be involvement of digital processes for dealing all the complaint of the patients. Like if I am just complaining, like, okay, I am some bone pain. So okay, then whenever I am just going to any hospital, then after that they are just checking my details, they are recording all the information in electronically, or directly we could say by using some computer, so that it could become electronic health record. So electronic health record means there would be involvement of all the details of a patient, including its normal background, as well as health problem, as well as its or the users lab report, medicine, everything is keep record in terms of electronic health records. And here in third point, you could find one important point, that is M health. So M health, that is basically mobile health. So in mobile health, whatever we are just doing, we are just getting the healthcare services in our mobile phone. Okay, so for example, we are just going through some treatment, and whatever the things are happening in the entire network or in the entire healthcare ecosystem, all those things are uh, available by using any mobile phone, or directly we could say what some application, mobile application. So as we already know that in, even though there is a mobile application, there would be involvement of EHR, that is electronic health records, so which are actually just transferred by over the internet. So as there is the involvement of internet, that means there would be the presence of many hackers and malicious users who continuously used to get the some user information. So in e-healthcare, there are many types, as we have already discussed EHS. So EHS belongs to all the information of like electronic medical records of any patients. Then computerized physician order entity, like what are the order the doctor used to keep, all those things are used to keep in some database. Then e-prescribing, you people already know, whenever we just go through any healthcare or any doctor, there could be some prescription, and those prescriptions could be directly generated electronically through some mobile through some computer, as well as some mobile phone, all those things. So these are e-prescribing. Then telemedicine. Telesurgery is one of the emerging areas in healthcare sector. Basically, here what is happening, there would be some robots. Through some robot, all the operation or surgery used to be done, so there is no involvement or small involvement of human or doctor. Then M health, we have already just discussed. Then sensors and wearables. So in sensors, you people already know that through some sensors, we used to collect all the information of human body, or by using some wearable device. There could be some wearable device like smartwatches. We used to get or we used to collect all the information of the patients. And whenever, for I'm just giving one example how the telemedicine works. For example, right now I am in Agartala, and there is one patient in remote area uh, uh, who is 5 kilometers away from Agartala. So I directly could not go over there due to some problems. So whatever we are just doing, there could be involvement of some sensor or some wearable device around the body of the patient, and there and those sensors and wearable device directly communicating through some information system, and they used to record all the details of the human body or the patient's body. And by analyzing those information, the doctor or any physician used to give some treatment or some medical advice, like, okay, these are the things should be done, or this medicine you used to take because your BP is low, or you have these problems. All those things are done remotely. So this is how sensors and wearable devices are used in a healthcare sector. So these are some features, as I have already mentioned earlier. Here, E does not only mean or does not only stand for electronic. It is the involvement of efficient, quality care, then enabling extension, ethics. Many things are involved in this particular E. Okay, so these terms you people can easily understand. So I am not discussing it. So in figure 6, you could directly see one simple scenario of e-healthcare. As we have already discussed, there could be involvement of patient, then laboratories, pharmacists, medical specialists, then infrastructure, then there would be involvement of government also, because the government is solely responsible for creating or forming the rules and regulations. So this is the involvement of e-health. So what are the advantage of e-healthcare? So first one is easy to use, because it is very easy through mobile phone or through internet. We could easily get all the information of any patient details. Then availability is there. Whenever we want, we could get all the details of our healthcare record. Then speed is there, that we could directly access in a small access our healthcare or EHS in a small amount of time, as well as we could easily get the treatment in a short span of time. Like, for example, right now I don't have time to go to hospital because it would take 1 hour to go to hospital. So whatever we used to do from home itself, we are connecting through mobile phone or through some internet or through some any other media, and we used to get some treatment in a short time. So if all those things are happening electronically or remotely, that means there would be no involvement, or there would be less requirement of physician or doctor. So that is in this way that there would be the efficiency in terms of cost, because if there is so many doctors, then of course there must be given some salary, and there would be some involvement of cost as well. So thus it is cost effective. Then data collection and overall improvement of patient outcome and communication, because communication is easy. However, there are some disadvantages, and among all the disadvantages, the first and major concern is data security. As I have already mentioned, that all the data are stored electronically in any database or any cloud server or anywhere else, then there would be the involvement of data security issue or data leakage issue, because at that time the data could be lost also, or our data could be used for earning some revenue. Okay, so if all those things are happening electronically or digitally without visiting or without visiting any hospital, at that time healthcare providers would not get any patient. So that's why it is actually just one kind of revenue loss for any kind of healthcare provider. Then trust. So for example, I am a patient and I am calling any healthcare system over my mobile phone, and I am just giving my problems, or I am just discussing my problem. So I don't know who is giving me reply, okay, whether that is a genuine doctor or genuine physician or not. I don't know. So that's why trust is there, and this trust issue is also could be is also solved by using blockchain technology. Then after that, difficulties to access electronic health information. So for example, if I am a patient and I am just visiting any hospital, so if it is e-healthcare system, that means I must have some electronic devices or electronic gadget to access all the information of my health, or to get all the information about EHR. Correct. So of course, the rural people could not be could not have that particular electronic gadget. So at that time there could be some issues. Okay, so that's how it is making some difficulty, or there is some difficulty to access some electronic healthcare information. Then ethical and legal concern, because there is no standard format which is maintained in uh, all the hospitals or all the healthcare infrastructure. Then increased additional cost. So how it is making additional cost, because here we need to make the entire system electronically, like all the information starting from equipment till whenever the patient fully recovered from any disease, till then all the things should be maintained electronically, so that one huge system or IT system is required to give the services, as well as some special software engineer or users are required to manage as well as to broadcast all the information, or to share the access right, as well as to if there is any maintenance kind of thing. Okay, I am just having this database, however the database crashed, then how those data could be recovered, how those data could be recovered from the database. All those things are there, and to manage all those things we must have some IT professional or some specific users should be there in the entire healthcare system. So to give them salary as well as to give them other facilities, there is the involvement of cost, as well as the company, the healthcare professional should go some training, and for the training also there could be some involvement of some cost or financial thing. Okay, so these are some disadvantages. So now how blockchain could be used in healthcare sector. So as I have already mentioned, like how data security is involved in the healthcare system. So as all the information are stored in digitally in any database or any cloud server, and those data are transferred over the internet. So there could be many security attacks by hackers as well as malicious users, because nowadays there many new attacks are being developed by machine learning algorithms as well. So it is the duty of the healthcare infrastructure provider or the main administrator to provide the security to the patient's confidential data. No data should be leaked, as well as no data should be given to the users who is not permitted to access that particular data. So this is actually the data sharing and interoperability comes into the phase. So how the data could be shared among different entities or in different modules, because like in healthcare sector there will be involvement of many many units. So all those things could be handled by using blockchain technology, because blockchain technology supports immutable data storage features. Once the data is stored in the blockchain network, no one could be tampered that particular data, because it is the cryptographic property is maintained in the blockchain network. Those I have just mentioned in the earlier slides, only the SHA-256. However, public key cryptography, private key cryptography has function. All those things are involved in a blockchain network that we'll discuss in detail in further slides. Trust. So how trust could be increased? As I have already mentioned, that in blockchain network, all the data is transparent. Any patient or any healthcare information in any healthcare professional could see whatever they are eligible for. So thus the trust could be increased. Like, okay, I am a doctor and I am eligible to see the details of the patient, whatever I have already gone through in past days. So if it is the case, and if blockchain maintains all those details, that means no one could tamper those details of patient who came to me for getting treatment. As well as the patient also could see the details. Okay, I am a patient. This is he or she is my doctor. He or she is my pharmacist. I am just getting the medicine from this pharmacist. As well as these are my lab technician. Okay, from them I just got some. I just have gone. I have gone through some medical test. So all those things could be seen by a patient or any user. So the trust would be increased. Then supply chain management. So basically in supply chain management, whatever we are just doing, we are just getting the information from first to last. First to last, that means from where a, for example, if there is any medicine. So to make that medicine, there will be some ingredient. So from where those chemicals means from where those chemicals were supplied, and from where those raw materials were supplied, and after that, what is the manufacturer, when the manufacturer just manufactured that particular medicine. After that, who were there in the logistic, and who are the retailer, who are the dealer, who are the wholesaler. Everything could be then most importantly, what are the feature of that particular medicine, like what is the color, what is the quantity, what is the size, then what is the dimension, that is actually size. So everything is just mentioned or maintained in the supply chain management process. So if we use the blockchain network in a supply chain management, so at that time all the information of that supply chain management process or any medicine could be stored in a block, and that the details of that block, as I have already mentioned, in a blockchain network, the identical information is just shared or stored or with it is just shared with so many nodes. For example, if there is any medicine, that the details of the medicine is shared with all the nodes. So thus that the supply chain management process could be handled. So because all the users could see all the details. For example, whenever a medicine just gets through that logistic process, the details of the logistic process is saved in the supply chain management process. And whenever it is just reaching to the wholesaler, then wholesaler is just giving its details, like, okay, I am the wholesaler, this is my identity, these are the batches of the medicine. Okay, all those details are gradually saved in the supply chain management process. And as blockchain is secured, and all the details are not all the details cannot be tampered, so blockchain would be used in this particular supply chain management process. Then accessibility, we have already discussed like how the data could be accessed and self-correcting, because if there is any mistake or any fraud in any data, because okay, after logistic, whatever the things is happening after logistic, there is any malicious users, and they used to just modify, they have just modified the details of the manufacturer. So as it is in the blockchain network, or as one blockchain network is used for maintaining that information of the particular medicine, then it would reflect in the entire blockchain network. Okay, this information has been changed by any users or any malicious users, like the details of the manufacturer is already saved. Now another user coming and he or she is trying to modify the details of the manufacturer. So at that time, it is actually just checked by the customer itself, or any entity could easily check. So securing patient data, we have already discussed. So benefits of blockchain in healthcare. Then crypto traceability, we have already discussed, like by using by using any supply chain management, as well as blockchain network. In blockchain network, there are so many nodes which are linked with each other, and as one block is linked to the another block, so that in such a manner that could be easily means we could easily trace the medicine as well as any medical equipment, like for medical tests which equipments are used, all those details could be easily traced by using a blockchain network. Cryptocurrency payment, so this is basically whenever we just get sorry, whenever we just get treatment from any hospital, and after the treatment we are just paying some uh, money or charges through some cryptocurrency. It is already in practice. Everyone health and micropayment are two example of this particular feature or particular service. Then improves electronic health record system. So here, as any data would be linked to the previous data, and all the information is stored in the blockchain network after encrypting it. So that means there will be no involvement of and tampering, and there will be we could easily or efficiently store healthcare information. Then smart contract for insurance. So basically here it is mentioned like how smart contract could be used. So for example, if there is any medical insurance is there, or if there is any urgency of medical insurance or health insurance, so whatever it is happening, I'm just going to any medical any hospital, then hospital is asking whether there is any health, any medical insurance or not. So if I am saying okay, yes, there is I have some I have one medical insurance, so whatever they will do, they will just click on the particular option. Okay, if that particular that the user is having medical insurance, after that the smart contract will be triggered, and all the information of the medical records would be available to the hospital or the doctor. Okay, for the patient this much of sum assured is there, like 5 lakh or 10 lakh, and then through smart contract all the details should be saved, like okay, these treatments are going through, or the patient is going through this treatment, and the cost of this treatment is this, and all these records are being stored in the blockchain network, and smart contract is basically handling all those tasks. So thus it is the entire system is getting automated. Okay, the next one is medical staff credential verification. Nowadays, whatever it is happening, many people are coming to the healthcare industry or healthcare institutions, and they are saying, okay, these are my credential. I have done my MBBS or MD course or MS course from these institutes. However, they used to give only some documents, but really there are some verification from the university. Okay, whether this doctor or some nurse, whether they have got their degree from that institute or not. So if we just save all the details of the medical professional or medical uh, workforce in the blockchain network. So from the blockchain network, we could easily get the details, and that would be last for a long time. And the data would also not be tampered with by would not be able to tampered by any hackers and malicious users. So thus medical the credential of any medical staff could be verified. Then decentralized storage and validation, all those things we have already covered and we have already discussed earlier. So I hope the uses of blockchain network in healthcare sector, it is clear. So basically, again, I am just repeating what could be the use, what could be the uses of blockchain network in healthcare. First one could be security. The second one is could be access control. The third one could be for improving trust. The fourth one could be for developing an efficient supply chain management system by using blockchain technology. These are main four use cases for providing an efficient healthcare service by using blockchain uh, for developing one efficient.
Your
Yes, ma'am.
voice is. Can you come again? Perhaps your voice was breaking, or I do not know if my internet connection was low.
Yes, ma'am. Is it audible?
Can you come again? Yes.
Now is it audible, ma'am?
You were telling something. I'm sorry, I could not listen.
Okay. Right now, can you get my voice properly, ma'am?
Yes, sir. Your voice is clear right now.
Yeah, perfect. Thank you. So I was just saying there are mainly four use cases of blockchain in healthcare system. First one is security, to improve the security of EHS, electronic healthcare record. Second one is to develop one efficient access control model. The third one is for improving trust by using blockchain network. And the fourth one is to develop one efficient supply chain management system by using blockchain network for any healthcare sector or healthcare infrastructure. So here I am just discussing one use case, like how blockchain technology could be used for serving one efficient for developing one efficient healthcare infrastructure. So what are the motivation over here in this particular use case? To provide a proper interface to all the entities of healthcare ecosystem. So as you people already know interface, that means how we are just communicating with each other. Like, okay, I am the patient and I am just coming to the hospital for directly for getting some treatment. Then how my information would be stored, and whether I am able to access the interface or not. If there is any doctor, then whether the doctor is getting proper interface to get all the details of the patient or not. Those things could be done by using or by developing one efficient interface. The second one is to implement a distributed application for healthcare system with IoT devices. So as I have already mentioned earlier, nowadays IoT devices are used because but through some IoT devices, we usually collect all the information of the patient, or there could be some sensors or wearable devices. Those are basically parts of IoT, because there is also connectivity of internet, and through that internet we are just getting all the information. And there could be involvement of distributed application, as we have already mentioned earlier. In DApp or distributed application, there would not be any centralized authority. Whenever we just use blockchain network, and all the information of any patient would be shared to all the users, and no one would be able to tamper it. Then security and privacy thing we have already discussed. And the last one is, the last motivation is to automate the entire task by using smart contract. Like, okay, I am a user, I just came here, or I just reached to any hospital for getting treatment. So what is the first task should be done? Okay, registration. So this registration task should be also done by using some
smart contract. Then there could be, for example, there could be some involvement of I just want to access my healthcare information from the hospital or through that particular interface. So at that time also there should be some smart contract. It is not like that, okay, I am just sending some request and it is just getting through means one person is providing me access after 10 minutes or after 1 hour. And most importantly, whenever the data are stored in the cloud, not cloud actually, in blockchain network, everything is saved in terms of hash value. So for example, I am a patient, my data is stored in the blockchain network, then I will be provided my data stored in the blockchain network, and at the time, after storing the data in that particular network or blockchain network, basically here IPFS is used. So after storing the data in the IPFS database, then one hash value is provided to me. Okay, this is the hash value. Through that ID or hash value, you could easily get the information of the EHS. Okay, so in this particular use case, there are mainly 4 entities are there. First one is distributed application. So what is the work of distributed application? Distributed application is responsible for developing a proper interface through which different entities could easily get all the information about the other entities, as well as the data should be stored properly, as well as the data should be provided to the users in a short span of time. Then users and IoT devices, I have already discussed it, so I am just skipping it. Healthcare experts. So what is the work of healthcare experts? So basically the healthcare experts is responsible for giving the treatment, and they used to get some credential by that particular distributed application. Of course, that distributed application also get that information, or they used to share the data with blockchain network. So here the main concept is that in between there would be distributed application or any kind of mobile application which is distributed in manner. Through this distributed application, all the entities are communicating with each other. There would be involvement of healthcare expert or healthcare professional who are giving the treatment and there is the involvement of users and IoT. So users or IoT, basically whenever we just get registered any IoT devices, there would be some involvement of ID of that particular IoT device. I have to provide the ID of the ID of the particular specific IoT device. Okay, this device is only used for the patient ID 101. So this particular sensor device or IoT device should not be used for another patient. Okay, so all those things are just dealing with the distributed application or the interface. And blockchain technology is used here just for providing the entire services in terms of hash, then smart contract to store the data, as well as to provide some consensus algorithm. So this is the entire workflow of the system. So you could easily find it out. There are so many processes happening here. There are 12 processes. So first one is registration. So whenever one user gets registered or any healthcare gets registered, so they must send one registration request to the distributed application just to get the registration. So whenever the registration process is completes, that basically here the distributed application receives the registration details and verifies if the healthcare center or healthcare expert, not actually center is the entire infrastructure, whether the healthcare expert is already registered in the system or not. If the healthcare expert is not registered, the whatever the distributed application is doing, distributed application stores the expert details in the blockchain network, because as I have already mentioned earlier, here blockchain network is used for storing all the details. Then after storing the healthcare expert details, the blockchain network generate the login credential for the healthcare experts and send them to the distributed application. So once, as I have already mentioned, all the communications are happening through that interface by using that distributed application, and once the credential are received by the distributed application, it is again again sent back to the healthcare experts. Okay, these are your credentials, these are login ID, these are public key, private key, these are some other keys that are used during the enter process. Okay, in the same way, the user as well as the IoT devices are used, the same steps are used for registering IoT devices as well as users. One differences for IoT devices is that whenever IoT devices get registered, at that time they must provide that unique ID so that it could be stored in the blockchain network by creating some hash value. And after that, in the fifth step, you could directly see that the user is just sending some request for getting some medical certificates, such as, for example, if there is any medical report or lab test report, all those are actually requested by the user to the healthcare expert. Then whatever the healthcare expert is doing, healthcare expert, in the sixth step you could directly see it. Healthcare center check the validity of the user from the distributed application, because healthcare expert does not know whether the user is authorized or not. For example, if a user wants to get any medical report, the healthcare expert verifies the user's health condition, then treatment period, like for how many days he got treatment, and the timestamp, and then who was the consulting doctor, all those things they used to take, and then it decide then whether that user request could be processed or not. In the seventh step, you could directly check it out. The users get means some information. Okay, it is verified, and the distributed application gets some validity and get some verification information from the blockchain network for getting some credential, and it is directly connecting to the blockchain network to provide the details of that already stored healthcare information. Then in the eighth step, what is happening? The blockchain network save the user details with the generated certificate details in the blockchain structure. So as blockchain structure means, as I have already mentioned, that in blockchain structure all the details would be stored in terms of hash and issues the generated unique ID of the certificate. This unique ID, from that unique ID there could be some hash value, or there could be anything related to the hash value of the requested medical certificates. And after that, once the distributed application got this particular ID and credential from the healthcare network, it is shared with the user as well as the healthcare expert, because healthcare expert is also responsible for giving the or for verifying the user details, that is mentioned in step number 9. Then the user is allowed to access the generated medical certificate with the help of the distributed application by using its interface. However, the main thing is that the hash value, whatever it is generated by using the blockchain network, it should be checked and it should be managed, and once it is verified once it is verified by the distributed application, then the certificate is issued to the user or any kind of patients. So there would be involvement of smart contract, as I have already mentioned that in a blockchain network, all the works are handled by the smart contract. So here, this is basically one algorithm in terms of smart contract. Okay, so I have already mentioned that nowadays smart contract is nothing but there is some involvement of if and else. In further slides, we'll just check it out how the entire smart contract is given. So first one is registration of health center. So in health center, what is happening? The health expert used to give its details like username, password, what is the preferred username, all those things to the distributed application, and then distributed application process the request, and after that as I have already mentioned that all the information is saved in the blockchain network. In the fourth step you could directly see it, distributed application pass this information or share this information with the blockchain network. After that, blockchain network process this information or that process this request, and in reply it generate the ID of the health center or any domain expert, and it is sent to the data distributed application, and then the distributed application is just the distributed application the share this ID to the health expert. So now you could ask me, sir, how this smart contract is involved. Basically what is happening here, this is nothing but only just used to write the entire algorithm in terms of if else condition. Only the difference is that there would be the involvement of so many functions, and if any function gets executed, then whatever the consequences or whatever the action could be triggered. As I have already mentioned, there will be the involvement of if else condition. Thus it is just one kind of smart contract to automate the entire task. This particular concept would be more clear in this slide, that is slide number 69. So in this particular smart contract, or directly we could say generate block smart contract, at first registered user sends a registration request, means not registration request, because here we are just generating the certificate. It is just sending one request to the healthcare expert with all the details. Then the healthcare expert checks whether the user is a registered one or not. Here the checking is done with the distributed application, because distributed application is the interface and all the things are happening through this distributed application. Whenever the verification process is completed and the user is authenticated, the distributed application passes and transfer the request to the blockchain network for further processing. After this process, the blockchain network performs some cryptographic operations on the user request. Here in the 7th step, you could check it out, and whatever the request is sent by the user for the particular certificate, it is just generated, and it is just added to the blockchain network in terms of block. In the end, the generated block is appended to the blockchain network by one miner. And whenever there is any mining process, there would be the involvement of some consensus algorithm. So that's why we have just discussed one consensus, briefly discuss one consensus algorithm, that is proof of work. A valid user can show their health documents using user ID without carrying any other physical documents. Okay, I am just going to any hospital, and I am just showing my user ID in which all the information of the user is already there and access the generated certificate. So in this step number 8, 9, 10, we could directly check and if the authentication process is not completed, or if there is any hackers or malicious user, then directly it would be rejected. So after that, we have in the last step, we have already generated the healthcare record or healthcare or EHS through the blockchain network as per the request of the users. Now, in this particular step, we are directly accessing, or we are just processing the user request for accessing healthcare certificate. So here the distributed application is again assigned with the unique ID as whenever we have just discussed the entire workflow. We have just mentioned that the unique ID is just shared with the distributed application as well as all the healthcare expert, and blockchain manages each unique ID of the transaction within a specific block. Because here, as I have already mentioned, in a block, all the details of the transaction are being saved. So that's why it is it is just going through blockchain. It is going through distributed application, and distributed application used to get some access from the blockchain network. Here, SHA-256 algorithm or any other algorithm could be used to generate the cryptographic hash value to interconnect a specific block. Like, okay, in this block, this is the details of the transaction of each user is saved. Okay, I am a user, my details are saved in particular block, and from that the hash value of that block could be shared in terms of ID or some value with the distributed application or some users, as well as, of course, involvement of the healthcare expert, because healthcare expert also must check the details of the user. Okay, the users are valid. However, all these things are happening through blockchain network. Only the interface is a distributed application, and all the communication would be conducted or occurred in terms of through any secure channel like SSL. Here, another thing I would just like to bring here: whenever an entity send one request, it is sent in the encrypted form. Like, whenever I am a user, whenever I am just sending one request, at first the request or the entire information or entire message would be saved by using my private key. After that, it would be again encrypted by using the recipient public key. And whenever the receiver will receive the entire message, the receiver will decrypt the message at first by using its own private key, and after that user's public key. Okay, so thus it is again making secure. Each and every communication process is happening in this manner. Another point here I would like to notice that, or I would like to bring into your notice that whenever any data is stored in the blockchain network, what is happening here? The particular data could be saved or could be encrypted before it is being outsourced to any blockchain network. For example, my information is there or my AHS are there, and those information could be stored by using some cryptographic algorithm. For example, I could develop one novel algorithm for generating any encrypted information, or directly you could say ciphertext. For example, I have some healthcare data. Like I have just gone through some CT scan. Okay, this information is there in the database. Before it is just stored in the blockchain network, whatever I am just doing, I am just encrypting the details of that particular report or CT scan by using any algorithm, any cryptographic algorithm. So here, this particular cryptographic algorithm, there could be some novel algorithm to encrypt this particular CT scan data. So whatever we could do, there could be two things. First one, as I have just mentioned, cryptographic algorithm. So whenever any cryptographic algorithm is there, there is involvement of some key or some secret key. Okay, so whenever there is an involvement of secret key, there could be another novel algorithm to generate the secret key. Correct. So for example, I am just using one algorithm based on DNA based cryptography. So whatever I am just doing, I am just developing two different algorithms. One is just for generating one key by using DNA based cryptography, and the second one is for encrypting the EHR, or directly we could say CT scan details, by using the novel encryption algorithm. And this novel encryption algorithm could be based on anything like ACC or like chaos based encryption or DNA based encryption. But as I have already mentioned that I have already developing one secret key algorithm or secret key generation algorithm. So in that novel encryption algorithm also, the particular secret key would be used. So now you could ask me, sir, how the how the communication would be happen. As I have already discussed earlier, like all the communication would be happening in terms of security, as well as in terms of encrypted form. Public key of the recipient would be used, as well as the private key of the sender will also be used. Another important point is that whenever some credential or registration confirmation is being sent to the user or any other healthcare expert, at the time itself, what are the credentials are used for generating that novel secret key generation algorithm, as well as novel encryption algorithm. All these things are sent to the user or patient as well as the healthcare center. Correct. And blockchain technology are used to save those details, because those details, once we just use blockchain technology, those details would not be, and it is not possible to tamper those information of the users as well as EHS, right? So that's how blockchain technology is used for developing some secret key algorithm as well as secret key generation algorithm. However, in this particular use case, I have not included those things. These things are actually anyone could implement as well as could be developed. Even some of my papers, those concepts are already used. However, in this particular use cases, those concepts I have not covered. Here, only 4 smart contracts are used. One is for not generating. First one was actually, I think, for registration. That is registration smart contract. Second one was for generating the healthcare certificate, and fourth one is for issuing healthcare certificate, and the last one is for verifying the healthcare certificate. But if you are interested, you could go through some research papers, like how encryption or decryption algorithm could be used in blockchain network. Most recently, nowadays, machine learning and federated learning, both the things are also being used in blockchain network to secure the blockchain network. So here, machine learning algorithms are used for developing novel algorithm for identifying attacks or for developing novel algorithm, like based on some specific pattern, we are just generating some keys, as well as we are just generating some or we are just developing some encryption algorithm, something like that. Okay, so this thing is happening in the background, or we could develop novel algorithms for by using blockchain technology. The main concept here in blockchain technology is that blockchain technology is used to store all the details in transparent manner, and the details are saved in terms of hash value, and for each and every user there could be one block. Basically, one block is nothing but a set of transaction. There would be the involvement of so many transaction, and all the transaction would be there in the block. And in the transaction itself, there would be the uses, or there would be the involvement of, or the hash values are stored in the blockchain network, or directly we could say in the block body. So as I have already shown the structure, the timestamp, nonce, all those things are managed whenever we just save any blockchain network, or whenever we just whenever we just develop any healthcare network or healthcare system by using blockchain network. So just let me cover this fourth use case. So the fourth use case is only for verifying the healthcare certificate in fourth algorithm or fourth smart contract. What is happening? It is basically checks the blockchain based unique ID of the user's medical certificate using the distributed application. It is already discussed, like all the communications are done by using distributed application. If the unique ID matches within the database, or whatever it is saved in the database, it verifies the document correctness. So basically, with the already saved details in the whatever the details are saved in the blockchain network in terms of hash, as I have already mentioned, one ID for one particular document is provided to the user, and for that particular ID there is one hash value, and it is checked with the data that the already saved details of the database. It is just checked like, okay, it is matching or not. If each unique ID of the user and generated certificate ID is managed in the blockchain network in terms of transaction in a specific block. And of course, if there is so many blocks which are interconnected, then we could easily track each and every connected. So as all the blocks are interconnected using a cryptographic hash value, that is SHA-256, we have already discussed. So any change in the particular transaction could affect the hash value of the entire block. Or directly we could say that the smart Merkle root hash of the entire block or entire network would be changed, because all the blocks are having some hash value, and if any changes is done by any attackers or any malicious users, then the root or the Merkle root hash of that particular network would be changed. So this is how basically this is one use case of the blockchain technology in healthcare sector. So now just let me discuss about some security analysis of this particular use case. So first one is we are just discussing about collision attack. So basically, an collision attack, whatever attackers are happening, attackers used to get information, or attackers, or for example, there would be involvement of some attackers, and they used to combine some information, and by using that combined information, they used to collide, and they used to attempt to get some information from the network. So here, as I have already mentioned in the particular use case, like for each and every document or healthcare document, one specific ID is generated, and which is only shared with the authorized user. and the entire communication is done or executed by in terms in the encrypted form. Again, I am just repeating, whenever any sender is sending the request, at first the sender encrypts the entire message by using its private key. After that, the receiver's public key. Whenever the receiver used to get this message, the receiver first decrypt the message by using its private key, and after that the receiver again decrypt it by using sender's public key. So as unique ID is mentioned or managed by each and for each and every document, so this attack could be easily handled. In the next attack, whatever it is happening, the particular use case utilizes the unique identification method to secure against this particular attack. Here, what is happening in this particular attack, it is initiated by many users by assigning several identities of the same node, and there could be one attacker takes control of multiple nodes in the blockchain network, or directly we could say distributed network, to initiate the double spending attack. So in this use case, whatever happening, the user or the patient is verified using the unique identity, and as the unique identity is mentioned for each and every document, and it is delivered in the secured manner and to one single entity itself, and no one, no third party or no one is involved in this in this communication process. Thus, we can resist this attack. Moreover, in the proposed application, or directly we could say the use case, whatever we have just discussed, the proof of work consensus algorithm is used for mining process. As I have already said, that whenever any user data is saved or shared with the blockchain network, it would be added to the blockchain network in terms of block, and in one particular block the details of all the patient would be saved in terms of transaction. So whenever the block would be added in the network, there would be involvement of any consensus algorithm. So in this particular use case, we are using proof of work and proof of work consensus algorithm. So thus the hacker must expend so much energy only to hack that, or to directly combat or directly to hack the entire system. As we already know that attacker could not have much efficient system or a high configured system to break or to find that mathematical puzzle that is used for proof of work. It is quite difficult for the attackers to break or to break the entire system by using this attack. That in the third attack, whatever the attackers use, they actually in this particular attack this allows the unauthorized user to use some random credential or some fake credential to get access of the system. So the use case deploys the registration service of the users for to prevent this actually masqueraded attack. So in this attack, the unauthorized user or malicious users cannot get any fake identity, because I have already mentioned all the communications are happening in the encrypted form, as well as the hash value or hash SHA-256 algorithm is used in the proposed application or directly or use case. So thus it is not possible for the attackers like without registering themselves in the network to get the details. Then the next one is phishing attack. We already know that in the phishing attack in the phishing attack, identical website or some other identical things are being developed by the attackers to get all the information by forcing the user, okay, this is the actual website, or you are just logging into the system. Even though it is not possible in to break the entire healthcare system by using phishing attack, because here SHA 256 is used whenever one user is logging into the system, its uh, credential or its authenticity details or are checked by through the blockchain network, because all the details are used or just stored in the blockchain network, and the distributed application just communicate with the blockchain network to uh, store the data. So here it is not possible to temper the blockchain network, because its features, and when the user sends one access request to the distributed application, at first it checks the authenticity, and whenever the authenticity is verified, then only its access is permitted. Correct. So thus this attack could be prevented in this system, in this use case. The last one is 51% attack. So in this 51% attack, what is happening? The attackers or malicious users used to get control of more than 50% node of the entire network. So as I have already mentioned earlier, like the miner must have a high configured system to mine the block, and in the blockchain network there would be involvement of many miners. So you just assume that whether it is possible to get the control of our more than 50% nodes of a blockchain network. Of course, it is not possible, because there will be the involvement of miner also in the network. So if you want to have the control of miners, then you must have high configured system or high computational power system. So to get this high configured system, you need to spend a huge amount of time, a huge amount of capital or financial aspect. So it is not practically possible to get control of more than 50% node in a blockchain network. So thus it is the not proposed exactly propose itself, or this in this use case, it is not possible to break the uh, entire system through this 51% attack. So these are some performance analysis, and I have included some results. So I am just discussing how the blockchain network could be developed. However, due to time, I am not discussing all those slides, because these results are taken one of my published paper. So I'll just inform you what about the paper. So directly you could, if you are really interested, you could directly go through that paper to understand the entire concept. So how the blockchain network would be developed? So there are 3-4 languages are required whenever we just develop any blockchain network. First one is like cryptocurrency and all, because whenever, as I have already mentioned, whenever any miner would add the details in the blockchain network in terms of block, like for example any healthcare aspect or any healthcare data, whenever it would be added to the blockchain network, the miner would get some reward. So for getting that reward, we could use MetaMask extension of the web browser. Then we need Remix ID. So Remix ID is basically used to give some platform to develop the entire system, or directly we could say the entire distributed application, or directly we could say the interface. Then Solidity language is used for for developing the smart contract. Moreover, Node.js as well as JavaScript, both the things are required to develop the entire system. By using all those things, we could easily develop blockchain network. So again, I'm just repeating what are the requirement. At first, we need we need a high configured uh, computer system. Then we need MetaMask as extension for developing the entire healthcare ecosystem. Then Premix IDE for developing interface, and Solidity language for developing smart contract. Then next one is Node.js. Then the last one is JavaScript. So by using this, we could easily develop one ecosystem for healthcare. So here about the conclusion. So in this presentation, one brief introduction about blockchain we have just gone through, and in the cryptography primitive we have just discussed a little bit about what is hash for each and every data. There could be some specific hash value. Then we have just gone through some brief detail about healthcare as well as healthcare and what are the application of healthcare. What are the applications of blockchain in healthcare as well as the benefit of blockchain in healthcare. And at last, we have just discussed one use case of blockchain in healthcare in detail. So what would be some future direction? As we have already mentioned earlier, that would be one proper blockchain based supply chain management process to deal with all the equipments as well as all the medicine or all the aspects of healthcare system. So basically, for equipment as well as for medicine, supply chain management could be used in a healthcare. Supply chain blockchain based supply chain management could be used in a healthcare system. Then there could be huge scope to improve the scalability of the blockchain network. Basically, here IPFS is used to improve the scalability. However, there are novel approaches are being developed to improve the scalability, because in many times it has been seen like whenever we just increase the number of users in the system, then it was very slow. And actually, in the background details, it was there for the mining process. It is actually taking huge time as well as huge energy. So if it is taking less energy and less time, then the entire system would be more efficient as well as scalable as well as flexible. So thus there is a huge scope to improve the scalability of the entire blockchain network. So the same thing it is written in the last point, that is the energy optimization, because as I have already mentioned, to mine any particular block for any blockchain network, whether it is healthcare or whether it is financial thing, or whether it is land application, wherever, or voting aspect, wherever we are just using to mine any block, we need a huge energy. So nowadays in blockchain 3.0, the scientists or academicians are working to minimize the energy for mining a block. So these are some future work direction in which you people could think about. So as I have already mentioned, the use case. Okay, so just let me show this references. So these are some references which I have just gone through for just developing my concept as well as to developing this use case. And whatever the use case we have just discussed today, it was just published in ASEAN transaction of on ASEAN transaction on sensor networks in last year, and the title of the paper is blockchain-based privacy preservation for IoT-enabled healthcare system. So thank you once again. So I think we have covered almost all the aspects of blockchain network in healthcare aspects. So I strongly believe that you people might have a strong idea like how blockchain network could be used in a healthcare system. So thank you.
Thank you. Thank you, Dr. Suel. Thank you so very much for your nice talk. Participants, if you have any questions, you can raise your hand so that we can unmute you, or you can write on the chat box, please. Any questions?
So
Yeah,
one
it
more
was a
thing.
nice session, Mekla. Yes, everybody's saying it's a nice session. Thank you. You were saying
Thank you.
something, Dr. Suel.
Yeah, I was just saying. So probably as I have just included, as I have included so many things regarding blockchain in healthcare. So probably some concept could be difficult. So if anyone is interested, then directly you could contact with me. So all the details are available on our institute website, or directly you could write mail, or so we could discuss.
Yeah, sure.
So thank you, ma'am. I think we could conclude.
Yeah, sure. I mean, on behalf of Asia Connect project team, I take this opportunity to thank you. And on behalf of two of us, Neelam Dayal and myself, we sincerely thank you for sparing some time for this important cause. And we hope to get your continued support in future as well. Thanks once again on behalf